Oh, wait, I need to fix the audio.
No, my mic was not okay.
There we go. All right. Can you talk for me?
Hello, lorem ipsum dollar stamet continuous set.
All right, you're good to go.
Okay, so sorry for a little bit late configuration. Hello again. My name is Emre. I'm a DevOps engineer. I have almost near 8 to 9 years experience. And disclaimer first, as we say, we are not experts on this topic. I'm a consultant, and we just like get paid for explaining these topics to our customers. But our informations may be not updated. So before pushing anything to production, it's better to do your own research. So all this week we talk about why the containers are great things, right? And today we will talk about how they are challenging. So let's start.
It died? All right, one second. Let me take a look. It's still all? Just this. Why did that happen?
Is it projector?
I fixed it.
Okay.
There we go.
Okay. Yeah. So today we will talk about why the managing containers is not an easy task. So, but first, why we need it? So the containers are really great things for having a small amount of code to small services, like running a microservices. And in the industry, last 10 years, we are just go to like the monolith applications to microservices. And also last couple of years, we are going the microservices to function as a services. I mean, the smaller amount of code running inside of a some function. It can be a Lambda, it can be other function, it can be anything. So as industry, when we go to the microservices, uh, the early days, while we hosting only one application, only a monolith application, right now we are hosting hundreds of small applications. So this means that we have to make sure that the network is good for 100 small applications. We have to make sure that they are healthy. We have to make sure that they are somehow staying alive in the production. And we have to make sure that these guys can talk each other. Also, these guys have to access the secrets. So this means that we have some place to store our secrets and broadcast these containers. Also, all of the configuration, like imagine that you have hundreds of containers and you have a database configurations or the other configurations, and you have to change them all. So this means that all of these configuration has to be come from somewhere, right? Do you have anything there? If you want to add something, you can just add it.
Let's go back one. So the thing with containers is that they're not meant to be long-lived, right? Or not necessarily that they're not meant to be long-lived, but containers, there's not a whole lot of focus on making sure that the container is always running, right? The idea is that the container should be able to die and you should be able to replace it. But the problem is, we've had a little bit of funky stuff with networking our containers, right? You had to create networks, they had weird IP addresses, all this kind of stuff. So there's this problem of like, you create a new container, but what is the IP, right? If you want to send traffic from the internet to that container, you need to route the traffic somehow. How do you do that? And if the container restarts and it gets a new IP address, or maybe it has to maintain some state, how do we handle that? That's another problem, right? And then, what if your container is a persistence layer, right? Maybe your container is doing log aggregation, like we were talking about yesterday. Well, How do you make sure that if the container dies, it gets the same disk, right? Maybe you have these containers running in a cluster. And if it's on a different node in the cluster, well, the disk it was using before is not available anymore. So what do? Right? And then there's also consistency, right? If you have containers coming up and down all the time, you have your network configurations will need to change, your disk configurations will need to change, everything will need to be, everything will need to change, everything will be dynamic. And that these are all problems caused by containers. Really, they're general clustering problems. So if you've heard of something like Zookeeper, Zookeeper deals with this kind of stuff even before the days of containers. But this is kind of the difficulty where when your application can just suddenly disappear, what do you do about it? So these are the kinds of problems that we need to figure out how to handle. I was just kind of restating what he said in different words. And then you talked about this already. So.
Yeah. So we have a general solution for finding IP addresses as containers. For example, we have a different product named container instances. So this is, we can say that this is kind of light version of the Kubernetes, or we have a ECS in AWS. Also, we can say that this is also the light version of the Kubernetes. So what this do is, so we define a service layer and we say that, hey, this is a user service. And then all of the containers which contains the user service code replica register this service discovery. And then when we just use the DNS connection of this service discovery and say that, hey, I want to go to the user service.local or user service something. And then inside of this network, you can just like jump into this container. But we need something to manage this service discovery. And also, if a container dies, this means that we have to remove the IP address of this container from DNS, right? So how we do that? Like early days, we were actually writing scripts inside the containers, and when the containers goes up, they just go to the service discovery and say that, hey, I'm alive, and register themselves. But when they die, how they tell that, hey, I'm dead, and please remove me from the DNS list. So we needed some solution here, right? And also, some containers sometimes dependent on other containers, or sometimes we have to get the logs of these containers. Right? For example, imagine that a container is running and you need to like somehow see that how much RAM and memory this container use, if it's crash, or like what is the metrics of this container. And also sometimes we have to move these containers. Like imagine that we have a physical servers, and this physical servers has a couple of containers, and we have a couple of physical servers. But I want to just do the maintenance work one of these servers. So I have to just move all of these containers to the another node, and then just make a maintenance to that physical server. But how I move them? How I move them without making application downtime? So, and also like these containers sometimes, like as we all know, if I just run a container and put a database in it, if this container restarts, I will lose all of this data, right? So I have to make sure that this container attached to a volume, a disk, or something that the life cycle of the container and the life cycle of data has to be separated, because a life cycle of a container may be short. Maybe you can just restart the containers. Like for example, most of my clients, their containers at least restart a couple of times in a day. But the data is just stored in somewhere, because we have to separate the life cycle of the data and life cycle of the container. So how we do that? How we dynamically assign a volume to a container, right? So we have these kind of problems and we have to fix them. And also orchestration. So how we launch the containers? Every time when we need a container, every time we will just go there and write that Docker run or Docker compose up. So this is also one of the issues. And also how we know that how many containers we need. Ah, well,
Oh, nope.
they're just hoping it's a fix because we're doing nothing and we're just waiting.
So for people on the stream, if we pause periodically, it's because one of the projectors is being a bit temperamental. And most of the people are on the side of the room where this projector is. So yeah. Right. So something's happening here where the signal is not getting sent to there, and the system somehow knows about it. But oh,
It's
is it coming? Hey, hey. Oh,
you mean to move projector or move people?
like move to that side. Oh no, there we go. We're good.
Yeah.
We're good.
Okay, we are good for 10 minutes.
Oh.
Let's
Okay. Well, the
Yeah.
presentation for this is less important anyway. It's just a list of bullet points. Yes.
While we're on technical issues, if anyone's having trouble to the Wi-Fi, connecting to the Wi-Fi, especially on a MacBook, I put some instructions in the Discord. So
You want to disconnect and connect
I
again?
know you can
Maybe.
connect to Discord.
Oh.
Did you touch
You have
anything?
to go
No.
and clear your DNS cache. and then- So if anyone's having issues.
I'm gonna disconnect and reconnect. Okay.
Okay.
I'll try the Windows solution. Unplug it, plug it back in. I'll have to also check that the stream was not all messed up.
Probably stream is messed up.
Yeah.
Okay.
Still not doing it.
Let me check the stream.
Yeah, it's fine. You'll have to share screen again.
Yeah, I share the screen, but the projector is still not working.
Oh, there we go. We just had to complain about it. Oh.
Since you said that,
Nah.
yeah, now it know that. Now it know our secret.
We can. Oh, what the hell is going on here?
Okay, let's finish this session without
Yeah.
slides because it's actually not important.
Yeah.
And until the next session, maybe we can just find an alternative.
Yeah.
Okay, orchestration. So we say that we need orchestration somehow. We need a lot faster. So let's imagine that we have a high traffic because we just publish an application. And this application is on the radar of some famous YouTuber influencer, someone. And this person just shared your application in their TikTok story. And what happens? A million people started downloading your application suddenly. So this means that you have to scale. You have to run containers. But what you do, you just like go there and say that, hey, that could run, compose up. No, right? So we have something to see.
Yeah, I'm working on it. I was trying to not interrupt him.
Is at the left. Okay, let me know.
Yeah, there you go.
Okay. Yep. So somehow we have to check that how much traffic we have, and somehow we need to how many containers we need to deploy, right? So we needed something that check that how these containers are using and decided if we need new replicas or not. Or sometimes, like for some containers, we need like NVIDIA GPUs, but some containers we don't have. So we have to say, hey, just deploy these particular containers to these particular physical machines with these requirements. But for these particular applications, just run them in this side. So we need to organize this container by container. We need to group them. We need to orchestrate them. And imagine that we have 200 containers. And this 200 containers, since we are running on the production, we have to just make them at least 3 replica of these containers running. So this means that we have to run 600 containers. And also we need the logging, right? So we need the log agents. We need the agents checking the health. We need the agents for checking the network. We need load balancers. We need firewalls. We need network stuff. So if you just add all of these, usually for like running a 100, 200 microservices company means that we have to deal with at least 900 containers. And dealing with these by hand is not a good option.
That's the last little bit. So there we go.
Yeah.
So back before the days of Kubernetes, there were ways to do this. They were just less than graceful. So who has heard of Docker Swarm? Wow, a few of you. How many of you have actually tried it? I am so sorry. So Docker Swarm, all it does is it allows you to run containers on multiple machines. That is it. If you want to figure out which machine a container is running on, or what that container's IP address is, or if you want to give environment variable configurations to that container, or if you want to allocate a disk to a container and then make sure that container stays on the node that the disk is on, good luck. You got to figure it out on your own. So you start with Docker Swarm, and then you're like, okay, I need service discovery. So let me go find Netflix Eureka. Okay, so I'm going to install Eureka on some node of my cluster. Oh, now I have to have Eureka clustered in order for that to work. Okay, so I need some kind of clustering solution beyond Docker Swarm. Okay, let me install Zookeeper. Zookeeper is a clustering solution. But now why am I doing a clustering solution for container stuff when I already have Docker Swarm for clustering my containers? This is weird. And then you're like, oh wait, no, I need to pass environment variable configurations and secrets to all of my containers. So then you install a console to get your environment variable configurations, and then you have to cluster that too. And then you're like, oh no, I have to handle secrets. Console is not good for secrets. It's only good for normal configuration. So then you install Vault, and now you have like 20 different services just to run like 6 containers on 3 nodes.
Imagine that also you have to set up a logging. So imagine you just set up a Loki, Grafana, Prometheus, and also their containers as well.
Yeah.
Most of these tools you also set up as a container. So many containers.
So to kind of summarize, the difficulty with containers is that these days we use containers to make sure environments are stable and that they're consistent, regardless of where you deploy them. So, and the goal is that you can deploy them anywhere. But the problem is when you're deploying them anywhere, where? Right? So basically, the problem that it's meant to solve of being able to run your services anywhere on any computer that you want creates the problem of now you're running it on any computer you want, and you have to figure out how to find the container and make it work. And so this, when Docker was first created, everyone's like, great, we can deploy stuff anywhere. And now they're like, oh no, we can deploy stuff anywhere, right? So there was a lot of time where we as like IT professionals kind of floundered for a bit And we're like, how do we do this? Okay, well, we can pull in this tool for service discovery. We can pull in this tool for environment configuration. Basically, that scenario I just described. And we did that for a couple of years, and it sucked.
Yep.
And so a few big companies, like Riot Games, for example, was building a tool called Admiral, which was basically Kubernetes. You could just basically, they had a code generation tool. You could produce a Golang service or a Java service or something, and it would automatically plug into their service discovery network. It would automatically plug into their environment variable configuration. It would automatically get some keys to access secret storage and all this kind of stuff. But it was very much focused on the application that was being built rather than providing a generic service. Whereas Google was making Kubernetes at the time, and they built it in a manner where it doesn't matter what the application is. The application doesn't need to know about anything, which is also more in line with the 12-factor app, which things had already been going in that direction anyway. And so with the combination of everything going towards the 12-factor app and Google building Kubernetes to be more of an environment setup rather than specific to how your application was configured, honestly, we got lucky. Everything just kind of, except with the projectors, everything just kind of came together at the right time. Wow, we're going retro, crazy colors. I wonder if it shows up like this in the stream. But anyway,
Probably.
I was not showing up. The stream just okay. Okay.
Well, we don't need for the people who watching the stream. There's a only question and question mark in the slide, so you actually don't need to see it.
Yeah. But so does anyone have? So basically, Kubernetes was kind of the savior for Docker. Basically, figuring out how to run Docker at massive scale or even at small scale on the internet consistently, regardless of the application being run. And so that's why we're going to basically spend the rest of the day talking about Kubernetes, because it solves the problem that Docker created in solving the other problems. So any questions about, or is there anything you want to add before we go to questions? Emily, is there anything you want to add before we go to questions? Or?
Well, no.
Cool. So questions about the problems with containers and why they're difficult, or did something not make sense in what we were explaining?
Okay, no questions at all.
So for our folks who tried Docker Swarm, do you want to share your experience a little bit? Or was it too painful to relive? It's not that bad. I'm being dramatic.
Like,
but-
what type of projects you try to use Docker Swarm? Who use Docker Swarm?
Yeah.
Okay. Why?
It's just one of my projects in university.
Uh,
I was studying container orchestration tool. So I tried it, but I didn't really like it. It was too confusing.
Yeah,
Too confusing makes sense.
and then Kubernetes will. It's confusing in a good way. Let's say it's confusing in a good way.
So when we start learning about Kubernetes in a few minutes, it is very complicated.
Yep.
It's its own ecosystems, it's its own infrastructure, it's its own big crazy thing. But it's complicated for a reason, and it's simpler than the alternatives. Because it is kind of a unified system. It does have really good support, and it's a lot easier than it used to be thanks to things like help. But when Emma goes over the introduction to Kubernetes and teaches you all the components, the reason that we went over the problems with containers first is to kind of provide context as to why we need all of these different components, why Kubernetes is so complicated, and all the different problems it's trying to solve. You need service discovery to figure out where your containers are. You need orchestration to make sure your containers are on the right node, either that the node has the physical hardware that the container needs, or to make sure that you don't put a container on a node that's already at 90% CPU utilization or something like that, right? So you have service discovery, you have orchestration, you have environment configuration, you have secret management, and you have disk management. Kubernetes handles all of this for you, right? But each of these is a different problem to solve that needs its own configurations and its own settings in order to solve that problem. So remember these different types of problems again: service discovery, orchestration, crap, I'm forgetting already, environment configuration, secret management, and disk management, okay? And also just general networking. If you remember these problems as context when you're learning about Kubernetes, it'll be easier to kind of slot your knowledge that you'll learn about Kubernetes into these problem sets, okay? Because you might be like, what is this service nonsense? And why do I need to define a service for every single thing I'm doing? Well, because that solves the service discovery problem, this kind of thing. Does that make sense? Great. All right, so we're quite ahead of time, but would you
Okay.
guys prefer a bit of a break, or would you prefer to start the Kubernetes stuff early? Break?
Break.
Okay, so we'll
Okay.
take a break, and we'll resume at 10:30 when we're scheduled to start Introduction to Kubernetes. Okay? Cool. Thank you, everyone.